We're talking about nth root and rational exponents. And in order to solve some questions going forward, we're going to have to talk about, we're going to have to remind ourselves of a couple things. So an nth root of A is written as the radical sign where the n is above the bracket, and then the A is underneath the bracket. So in this case, these two statements are equivalent. The nth root of A is equal to A to the 1 over n power. So if we're going to rewrite this, basically anything that shows up in the denominator of the exponent is allowed for us to put on the bracket of the radical. We have a little note here. If n is even, then A less than 0 has no real nth roots. And we'll talk a little bit about that in a second. Real nth roots of A, let n be an integer and n is greater than 1. And let A be a real number. So n has to be an integer, has to be greater than 1, and A can be any real number. A is, we're talking about n is an even number, n is an even integer. So an even integer would be 2, 4, 6. Any of those values keep going from there, 8, and so on. If A is less than 0, there's no real nth roots. Now let's take a look. For this one right here, can we say, if we take the square root of a number that's less than 0, say it's -4, can we take the square root of -4? Well, we can, but it's not real, right? We can take the square root of 4, which is 2, but then if we have the square root of -1, that becomes I. So we can have plus or minus the 2i. If A is equal to 0, there's one real nth root, and that just says if you take the square root or the fourth root or the sixth root of 0, then it is 0. So let's say we take the sixth root of 0, that's still 0. If A is greater than or equal to 0, then we're going to have two roots. So it's going to be plus or minus A to the 1 over n. So we can use our first example. If we take the square root of 4, we know the square root of 4, we could have plus or minus 2. All right, so now we're talking about odd integers. In odd integers, 1, 3, 5, and so on. So if A is less than 0, this is different than when we had an even integer. Let's take a look at an example. So let's say we're taking the third root of -27. The third root of -27 is just one value, it's -3. -3 multiplied by -3 is 9, and then multiplied by -3 again is -27. So that's one difference between having odd integers and even integers. We can take roots of odd numbers if we have, we can take roots of negative numbers if we have odd right on the radical. Same thing for A is equal to 0. So let's say that we take the fifth root of 0. The fifth root of 0 is still 0. So that's the same as it was before. And if we take, if a is greater than 0, meaning like a positive number, so let's say we take the third root of 8. The third root of 8 is 2.